I think you're going to have an easy time with this week's material. This week we're going to be talking about the first derivative test. Next week we're going to be talking about the second derivative test, which is also fairly easy if you do it the way that I show you how to do. This week and next week are almost identical. The only thing that's different is what you're finding. This week we're going to be finding where a function is increasing and decreasing and where its max and mins are using the first derivative test. Now obviously, if you have a calculator, you can just graph the function out. You can figure out where the max and min is, where it's increasing and decreasing. However, on the AP test, they always have a problem like this where you have to find it without using a calculator. And it's rather easy to do. It's not a tough one to do. Okay, so using the first derivative test to find relative extreme. The first derivative test for local extreme at a critical point. So what we're going to be doing is we're going to be finding the derivative. Then we're going to be setting it equal to 0. Then we're going to be setting up a table. It's called the first derivative table. And that is going to give us the values of the max and mins and where it's increasing and decreasing. So you can have a local min, a local max, and it always has to be where the derivative is set equal. Now, if it's undefined, we don't have a max or min. So there's times where there aren't any max and mins, but most of the times we will be able to find them. So this week, if I was to give you a problem like this, it says use the first derivative test. Now, as I said, if you have a calculator, it's not a problem. I mean, I can look at this problem and I can say, okay, there's a max here, there's a min here. It's increasing from negative infinity to 2 or negative 2. It's decreasing from negative 2 to positive 2, and then it's increasing from positive 2 to infinity. I can see that just by looking at the graph. However, we don't have the luxury of being able to look at graphs all the time. So this is what we're going to do this week. Step number 1, we're going to take the derivative. Okay, so that's a pretty easy step. So I'd end up with 3x squared minus 12. Second step, we're going to set our derivative equal to 0 because that is where the tangent is equal to 0, and that's where we're going to have a max or min. So I just set this equal to 0, solve it. So I have 3x squared equals 12. X squared equals 4. Take the square root. So I know that x equals plus or minus 2. All right. Once we have that, so we've taken our derivative, we found where our critical points are going to be. Then what we do is we set up a table. And our table is always, and we call this a first derivative table because we've taken a first derivative. And then we're going to do an interval. And we always start with negative infinity over here, positive infinity here, and then we put our two numbers on here. So we have negative 2 here, positive 2 here. So these are my intervals from negative infinity to negative 2. So I just write that down. Negative infinity to negative 2. I'll put negative 2 up here. And then I've got negative 2 to 2 and 2 to infinity. And then what we're going to do is we're going to fill in this table. And the first thing we're going to do is we're going to find out if it's positive or negative, because this interval will always be positive or always be negative. So all we have to do is we have to pick a number in this interval, plug it back into our derivative. So this is my derivative. Usually I'll just write that off to the side someplace so I know that's what I'm plugging it into. So I've got 3x squared minus 12. Okay, so I'm going to take, let's say, negative 10 here. I'm going to put negative 10 in here. Negative 10 squared is positive 10. Sorry about that. Positive 100. 3 times positive 100 is 300 minus 12. And I don't even care what the value is. All I care about is it positive or negative. This is definitely positive. This whole interval from negative infinity to negative 2 is positive. That means my function is increasing between negative infinity and negative 2. And we knew that because we could just look at the graph. And then between negative 2 and 2, I'm just going to use 0. If I put 0 in here, I've got 3 times 0 squared, which is 0. So this is 0 minus 12. That's a negative number. I don't care what the negative number is. Makes no difference. All I have to know is it positive or negative? So it's negative. So between negative 2 and 2, I know that this function is decreasing. And then I'm just going to take a number out in here. Let's take positive 10. If I put positive 10 in here, this is definitely going to be positive. So it's increasing. This is called the first derivative test. So I know that this function is increasing from negative infinity to negative 2. It's decreasing from negative 2 to 2. And it's increasing from 2 to infinity. And then I can tell where the max and mins are, because if a function is increasing and then it decreases, and I always just draw it out like this is a maximum. So I know at negative 2, when x equals negative 2, there is a maximum value. And then the function is going to decrease, and then it's going to increase, so I know that it's going to look like this. So at positive 2, when x equals positive 2, there is a minimum value. Now, I could find the maximum value and minimum value, but I'd have to go back to the original function to plug my values back in there to see what that value is. But this is called a first derivative table. And what does a first derivative table give us? It gives us where the function is increasing and decreasing. It also gives us max and min values. So that is basically it for today. That's all we're learning, is how to set up the derivative table and where to find increasing and decreasing values. So let's take a look. Okay, so this is just written out nicer than I did it. So here's another problem. Okay, we have x to the third minus 12x minus 5. I want to find the values where it's increasing and decreasing, and usually I'll ask for max and mins too. So first step, we're going to find the derivative. And we're going to set that equal to 0. So this is 3x squared minus 12. Set it equal to 0. So 3x, this is the same problem. What am I doing here? Is it? Well, maybe not. Maybe that. Yeah, it is. That's the same problem. Because it's going to give us 4, take the square root, it's going to give the same thing. All right, here's a different one. All right, so I've got 2x to the fourth minus 4x squared plus 1. Step 1, take the derivative. Okay, so now this problem here, if I didn't have a calculator, there's no way I'd be able to tell you where it's increasing and decreasing, where the max and mins are. But with just a little bit of work, we'll be able to figure all that stuff out. Okay, so the derivative of this function is going to be 8x to the third minus 8x. I'm going to set it equal to 0. I'm going to factor out the greatest common factor. It looks like 8x. So that gives me x squared minus 1. Well, so now I have 8x. I can factor this to x minus 1, x plus 1. So what are all my critical values? So whatever makes this equal to 0. 0 makes it equal to 0. Positive 1 does. Negative 1 does. Now, I don't usually draw out this interval thing here, but when I first start, I always do, so kids understand where I'm getting my intervals from. So I'm just going to put my numbers on here. So this is negative 1, 0, 1. So if I make out my first derivative table, f prime of x, my first interval is negative infinity to negative 1. Then I go from negative 1 to 0. Then I go from 0 to 1. Then I go from 1 to infinity. That's my table. I have to figure out where everything is positive and negative here. Okay, and my derivative, and I can write out my derivative any way that I want. I'm just going to leave it as 8x plus x squared minus 1. Okay, so I'm going to take a value in here, and it doesn't matter what value you take. It doesn't matter negative infinity to negative 1. You can take anything. I always try to take something that's kind of a nice number to use. So I'm going to go negative 10. So I put negative 10 in here. 8 times negative 10, that's negative 80. And then this is going to be negative 10 squared, that's 100. That's 99. Well, this is going to be negative. I've got a negative number times a positive number. That's negative. I don't care what the value is. It makes no difference at all. I just need to know, is it positive or negative? That's it. Okay. So now I'm going to take a value here. Well, there's not a whole lot of values. And you can't use the endpoints. So I'm going to use negative 1/2. So if I put negative 1/2 in here, negative 1/2 times 8, that's negative 4. And then negative 1/2 squared, well, that's 1 positive 1/4. So 1 positive 1/4 minus 1, well, that's going to be negative, isn't it? No, that's going to be negative because this is a very small number. It's 1/4 minus 1. That's going to be like negative 3/4, but I don't care. I just need to know it's going to be negative. So now I have a negative times a negative, which is positive. So now I'm going to take positive 1/2. So 8 times positive 1/2 is positive. 1/2 squared minus 1, that's negative. Positive times negative is negative. Then let's take 10 here. If I put 10 in here, that gives me 80. That's positive. If I put 10 in here, 10 squared is 100 minus 1, that's positive. Positive times a positive is positive. So my function is decreasing. Then it increases. Then it decreases. Then it increases. So if it's decreasing, then increasing, there is a minimum value. At x equals negative 1, there's a minimum value. Then it increases, then decreases. So at 0, when x equals 0, I have a maximum value. And decrease, increase. So at x equals positive 1, I have a minimum value. So the first derivative test gives us a lot of information about that function. And if I really wanted to, graph this thing out without a graphics calculator, I would put negative 1 back in here. Negative 1 to the 4th is 1, so that would be 2, minus negative 1 squared is positive 1, so 2 minus 4, that's negative 2, so that's negative 1. So I'm at negative 1, negative 1, that's a point on my graph. And then if I put 0 in here, 0 is pretty easy because that's just going to give us 1. So at 0, it's at 1. And then at 1, I'm going to put 1 in here. I think I'm going to get the same answer. Am I not? So I'm going to get 1, negative 1. So there's another point. So my function is decreasing till it gets to here. Then it's increasing, decreasing, increasing. That is what that graph looks like. Now, I don't have a graphics calculator with me, but I bet you if you put this in to a graphics calculator, you're going to get this graph. I mean, my graph should have kind of went like this more, but that's what the graph looks like. All right. Any questions on the first derivative test? Because you're going to end up getting the next problem. All right. So let's try this problem here. It says use the first derivative test to find the relative extreme. So I want you to find max, mins. I want you to graph it at the very end also, because that's usually what I have kids do on a test. Is I would have them find the max, mins. I'd have them find where the function is increasing, decreasing, and then I would have them graph it, because that's what we're really doing here. Is we're being able to look at a function, be able to tell where it's increasing, decreasing, and be able to graph that thing. All right, so I'm going to give you about 5 minutes. I'm just going to turn off my mic. I'm going to let you work, see how far you get. Okay? All right. How far did you make it? So did you make the, were you able to get the table done yet? Awesome. And I don't know if that is correct or not, but I would assume if you're doing it, it is. So let's work this through for people that are going to watch the recording. First thing I'm going to do, again, always, is I'm going to find the derivative of the function. So f prime of x equals 12x to the third minus 12x squared minus 72x. Now, this is where being able to factor is a huge, and this is one of those things where, you know, when kids say, Mr. Shanklin, this stuff is way too hard, a lot of times it's because they don't know how to factor. In this problem, I would have pulled out a 12x, and that would leave me with x squared minus x minus 6, I believe. And then I'm still going to factor this thing, so I've got 12x, x minus 3x plus 2. So what are my critical values? Well, anytime you factor out an x, 0 is a critical value. Then I've got positive 3, and I've got negative 2. So those are my critical values. So I'm going to set up my interval thing here just so I know what I'm doing. So that's negative 2, 0, and 3. All right. So now I'm going to make out my table. F prime of x, because it is the first derivative table. So negative infinity to negative 2. Negative 2 to 0. 0 to 3. I have to really write small. 3 to infinity. All right. Get smaller and smaller as I want. So now I have to figure out if it's positive or negative. All right. So now you can use this. So I'm going to use this just to show you what I'm going to do here. Okay. Don't care about numbers. Just care about positive, negative. So I'm going to take negative 10 here. I'm going to plug negative 10 in. 12 times negative 10 is negative. Negative 10 minus 3 is negative. Negative 10 plus 2 is negative. So I've got a negative times a negative times a negative, which is a negative. So I don't even care about multiplying any numbers out. Here, I'm going to take negative 1. So I put 12 times negative 1 is negative. Negative 1, that's negative. Negative 1 plus 2 is positive. So I have a negative times positive, which is positive. Then between 0 and 3, let's take 2. 12 times 2 is positive. 2 minus 3 is negative. 2 plus 2 is positive. So I've got positive, positive, which is negative. And then I'm going to take 10. That's positive, positive, positive. So now I have decreasing, increasing, decreasing, increasing. Does it always go that way? Does it always go decreasing, increasing, decreasing? No. There are times they'll trick you and they'll put decrease, 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 then increase. And it's like, oh man, they're really messing with our heads here. Okay, so it does happen that it doesn't always go back and forth. So you got to be very careful with that. So that means if it's decreasing, then increases. I have at x equals negative 2 a minimum. Then it increases and decreases. So at x equals 0, I have a maximum. And then it decreases and increases. So at x equals 3, I have a minimum. That's exactly what you had. Awesome. So now, I mean, I could graph this out, but I'm not going to because I don't want to have to plug negative 2 in here and come up with a value and all that kind of stuff. The only one I could come up with real quick is 0, 0. that one is easy to put 0 in there, but the other ones are going to be a little bit too tough for me. So I'm just going to leave it. But so if I knew this graph, I know 0, 0 is a maximum. So I know that these are going to be below there, and they're probably both the same. So then my graph is probably going to look something like this. would be my guess, because 0, 0 is the maximum in that interval. So I would assume that the graph looks something like that. That is it for this week. Let's take a look at a problem from the assessment. Oh, let's do this one. This is a pretty good one. It says find the critical values and determine the intervals where f of x. Now this is a problem off an AP test. Now, are you taking the AP test, Isabel? Okay. There's 4 sections to the AP test. Did you know that? Okay, there's 4 sections to it. Okay, so you know that there's going to be a multiple choice with calculator, multiple choice without calculator, free response with calculator, free response without calculator. So there's really 4 parts to the AP test. So in this problem, this is a non-calculator portion of the test. That's multiple choice. So I'd like you to work that out and see what you get for an answer. All right. A is your answer. Okay, so if I was going to do this problem, just for the people that are going to watch this afterwards, first thing I'm going to do, find the derivative. So that's going to be 3x squared plus 6x minus 24. Next thing I'm going to do is I'm going to factor out a 3. So that gives me x squared plus 2x minus 8. And then I'm going to factor that down, x plus 4x minus 2. So negative 4 and positive 2. Now 0 is not one of my values anymore because I didn't pull out an x, so that can't be. So now I'm going to set up my table. So I'm going from negative infinity to negative 4, negative 4 to 2, and 2 to infinity. Okay, so I'm gonna, let's see, I'm just gonna use this. I don't need to put the 3 in front because the 3 is positive. It's not gonna change. It's gonna be positive regardless. So I'm gonna use negative 10 here. That's gonna give me negative. That's gonna give me negative. Negative times negative is positive. I'm gonna take 0 here. That's gonna be positive. That's gonna be negative, which gives me negative. And then I'm gonna take 10 here, and that's gonna be positive and positive, which is positive. So I know. And what was the question? Find Find the critical values, determine the intervals where f of x is increasing and the intervals where f is decreasing. Okay, so increasing from negative infinity to negative 4 and 2 to infinity, and decreasing from negative 4 to 2. You are absolutely correct. Letter A is the correct answer. Very nice. Excellent. So this is kind of putting together, being able to take derivatives, factoring, all that kind of stuff. Now, I want to do a problem off tonight's assessment. That's the same thing. All right. Here is a problem off tonight's assessment. Now, I do have, if you take a look at part C, it is exactly the same thing as part B. But in my directions, because there's 4 problems just like this, part C is supposed to be decreasing. So anytime it says list all the intervals which f of x is decreasing. Okay, I just noticed that last night when I was making out my answer key. So B is find the intervals where it's increasing. C is where it's decreasing. List any max, local max and local min. So let me go down so you can see the problem again. Oh no. What did I? Oh, I know what I did. Okay. All right. So there is the problem. I want you to try it and see what you get. It's a decent problem. I think this is like number 2 or 3 on the assessment. And that this will be the last problem for today. Because that's all we're doing is using the first derivative test. Next week, we're going to be doing the second derivative test. And second derivative test gives us concavity and inflection points. So that's what the second derivative, and you can probably guess what we do next week. And we take the second derivative, make up a chart just like we did, find out where it's positive, negative. It's positive, it's concave up, negative, it's concave down, and wherever it changes, you have an inflection point. So next week is pretty easy also. And next week is a long week. It takes in consideration next week and the following week's 3 days. So next week is the last session before the holiday break. Yeah, we love those long weeks. All right, I'm going to turn off my mic. You work on this, see what you get for an answer. That is why I put that problem on there. All right, so in this problem, same thing. We always start the same way. We are going to find the derivative and set it equal to 0. All right, so in this problem, I'm going to use, I'll put it over here, u, oh no, u is equal to 9, u prime is equal to 0, v is equal to x squared minus 4x plus 7, and v prime is equal to 2x minus 4. So, quotient rule. Inside, well, 0 times anything is 0, so that's going to be 0. So I've got 0 minus outside, so that's going to be 9 times 2x minus 4, so that's going to be 18x minus 36. But that's a minus sign. So that's going to be negative 18x plus 36 over bottom squared. So that's going to be x squared minus 4x plus 7, quantity squared, set it equal to 0. Well, this is a proportion, so I'm just going to cross multiply here. So I end up with negative 18x plus 36 is equal to 0. Bring the 36 over, negative 18x equals negative 36. X equals 2. So now you also have to worry about, in problems like this, is you have to worry about what makes the function undefined, because that's going to be a critical value also. So what's going to make this function undefined? Well, I've got 7 and negative 4. There really isn't anything. It's going to be an imaginary number here, so I don't really have to deal with that for this problem. But if this did factor out, I would have to look for those. So I'm just going to look at x equals 2. So I've got negative infinity to 2 to infinity. If I plug, and you know, this is my derivative here. However, the bottom is always going to be positive, right? Because you're squaring it. So the bottom will always be positive. That's not going to change ever. So we really don't even have to use it. We don't have to put it in there because, you know, if it's positive, it's positive. We don't have to deal with it. So then the next thing I'm going to do is I'm just going to check out my values. So I'm going to take 0. If I put 0 in here, that gives me positive 36, so that's positive. If I put, let's say, 10 in here, it's going to be negative 180 plus 36. That's going to be definitely negative. So I've got decreasing here, increasing here, decreasing here. So then all I have to do, I just have to go up to the top, find all the critical points, x equals 2. Find the intervals for where it's increasing, from negative infinity to 2, it's increasing. And from 2 to infinity, it's decreasing. Local max would be at, increase to decrease, so local max would be at x equals 2. Local min, none. Now, I did graph this out to see what it'll look like. The graph of this function looks like this. Let me get a different color here. This is positive 2 right here. So it looks something like this. And does that go along with what we found? Well, it's increasing from negative infinity to 2. Yep. Then it decreases from 2 to infinity. And then its maximum is at 2. So this graph does. So I always look at the graph to see if my answer matches up with what I did. And this time it did. My graph matched with what my answer was for the problem. So that is not cheating. That is using a graphics calculator to see if what you did is correct. All right. Any questions on any of this stuff? I mean, as I said, it's a pretty easy week using the first derivative test. Let me ask you one more question before we leave. This is another problem off the test. Basically goes along with this one here. However, I was thinking that some kids are going to not do well getting the derivative here. What is the derivative of e to the 3x plus 2 minus 3x? Okay, what is the derivative of that? Three e to the 3x minus 3. I agree with you. Okay, one more question. Set it equal to 0. Solve for x. What would x equal? I'm not sure what that question is. E has to be to the power of 0. What does that mean? E to the 0 is 1. I agree with that. That is a true statement. Okay. So if I was going to solve this, I would add 3 to both sides. So I'd end up with 3 e to the 3x plus 2 is equal to 3. Then I would divide through by 3. So e to the 3x plus 2 is equal to 1. Well, that means this has to be 0, doesn't it? In order for this to be true, this has to be 0. So I just said 3x plus 2 is equal to 0. Subtract off 2. If x is negative 2/3, this would equal 1, correct? So my critical value for that problem is going to be negative 2/3. Okay? And that's all I can help. That's 2 out of the 4 problems on the assessment. Boy, oh boy, getting too lax in my old age. All right, that is it for today. Any questions? All right, we'll see you back next week for the last e-session of the year. Because when we come back, it'll be 2022. Bye.